Today we're going to be discussing some of the equipment we'll be using in these learning tutorials. In particular, we're going to look at the multimeter and at a solderless breadboard that we'll be using. A multimeter will be used to measure voltage, resistance, and amperage. Now, a lot of multimeters, especially cheap ones, do not give you the ability to measure amperage. We're going to put that down as a requirement since this is learning. It'd be nice to have auto ranging, which selects the range, for example, for resistance, ohms, kilo ohms, whatever range. It would also be awfully nice to have auto off. And basically that saves you an awful lot of battery since I'm always forgetting to turn mine off. The auto off is a really nice feature. The last thing, since this is for hobbyists, we would like it to be cheap. Now, I'm going to be looking at 2 meters. One is a Fluke 115 that I've had. It's a fairly expensive meter. The other is this Thinsti 18B Plus, and I'm not sure I pronounced that right, but I'll refer to it from now on as the 18B Plus or the Fluke. Basically, one of the reasons I chose this was that this is very inexpensive, I would say. It meets all our requirements. It meets all the nice things we'd like to have. And at the time that I'm making this episode, it was only $21 on Amazon. The Fluke is over 10 times more. It was $226 on Amazon. So we're going to be doing a lot of comparison of these 2 meters. So let's start by measuring voltage. Well, the way we measure voltage it seems pretty obvious to me that we have to have our circuit constructed and we have to basically measure it in the circuit. And this is the example of a simple circuit with a battery as our voltage source. We have 2 resistors, and basically we'll measure it by putting our meter across one of the resistors, for example. All right, so on the Fluke, we have 2 settings. We have, this is volts DC, because it's got a straight line. The AC has this wiggly line. And then we have millivolts, which is AC and DC on the same selector point. And you basically have to use the select button up here to choose between them. On the 18B, we also have 2. We have the digital voltage, and then we have the millivolts AC and DC, and you have to use the selector. So when I measured the voltage on a particular circuit, and I tried several circuits, and they were all about the same, you get very, very close comparison, I would say. Definitely close enough for what we want to do. And the things I want to point out is you can see that this is measured in volts and DC. Here is the volts and DC indication on the Fluke. So millivolts, again, very close. I mean, this to me it's hard to tell who was really right. This is millivolts in DC and millivolts in DC. Now, we've already talked about if we measure, we've got to look and see what we're actually measuring. Is it millivolts? Is it volts? Because in our formulas, we're going to have to substitute in volts. So we want to write down what were the units we actually measured it in. The next thing we want to use our meter for is measuring resistance. And Resistance, we have to measure the resistance, for example, of this resistor out of the circuit. If we tried to measure in the circuit or with any sort of power on, we would get not only the resistance of this, but any other circuitry in here. So we must measure this out of circuit. Again, there's a slight difference here. On the Fluke, it's just ohms on this selector, and then this is a continuity. It does a little beep if there is continuity. This is it also gives you the ohms, but there's a slight beep. The difference is on the 18B, it's got several things on the same knob indicator button. It's got the ohms, it's got the continuity, it's got, this is diodes, and this is capacitance. So it's kind of nice to have this on its own because it's hard to screw up. This you've got to, make sure that you've selected the right thing here and that you're actually measuring the right thing. But that's for the difference of 10 times in expense. That's a minor detail. So if we looked at measuring the same resistor, these are different resistors, obviously, but on the 2 meters, we see that again, they're very close. And as far as the ability to measure resistance, I would say that the 18B is as good as the Fluke. Now, one last thing of measuring resistance is you do not want, I don't know whether you can see it, there's a resistor. What I'm doing is I'm holding the probes in my fingers up against the wire of the resistor. And that can give you false readings, so you don't want to do it. Your skin in your body actually has a resistance, so you're measuring not only the resistance of the resistor, but also of your body. This isn't too bad when it's a very low resistance, like even at the kilo-ohm level, but our body resistance is basically mega ohms. But it's just not a good practice. The good practice is to put it between a couple of clips and measure it this way, so you're not touching it at all. Now, the next thing we want to measure is current. And current is the electrons going through the wire, so we have to actually break the circuit, put our meter in line with the wire, and that's the only way you can measure it. Now, for measuring amperage on both meters, we have to change our probe. We have to move our red probe over to here. And on this one, we have actually 2 settings. This is for up to 10 amps, and this is if you're measuring milliamps or microamps. Here we only have 1 setting on the knob, which is the straight line, meaning amperage DC. On here we've got 3. There's the amperage AC or DC, so we have to use the select knob to make sure we're on DC. Millivolts AC or DC, milliamps AC or DC. Again, we use our select knobs, and microamps. But you do have to move this over to depending on which you're measuring. Now, I always suggest you start out at the highest level. So we would start out at amps, and we would start out, well, there's only 1 here, but we would start in amps. The reason for this is, in case it is, you don't want to screw up your meter because you miscalculated or something. You can always step down later. Now, I only measured this really with the 18B, and I found it to be very accurate when I compared it. You can see that when you're doing amps, you plug it into this value. When you're doing milliamps or microamps, you're plugging into here. And these are different circuits. I had to do that to get it down to that level. But I found it compared very well with the Fluke. The thing I didn't like was the microamp setting on this level. It did not check out. It was only about 20% accurate. We don't need it, I would say. Just forget about using microamps. Only use milliamps and amps. And in almost all cases, for what we're doing, we'll be doing milliamps. Now, I want to make a few observations about these two meters. The 18B doesn't appear to have as strong a case as the Fluke does. It just seems more solidly built. But I've owned that 18B for about a year and a half, and I've used it just so I could recommend it if I liked it. And I've dropped it from my train table several times from about 4 feet, and I haven't dented it, I haven't broke anything, it still works fine. So even though the case isn't as strong, I just wanted to point that out. The accuracy appears to be adequate, especially for hobbyists, and it seems to be very cost effective, because for hobbyists you don't want to spend $220. I'd rather spend that, for example, on an engine or something. I just wanted to also point out, I don't know who makes this. I have no connection with these people. I found it on Amazon. I did some research on it. Other people seem to like it for the price. So I'm not getting any kickbacks. This is just an independent opinion. The next thing we want to talk about are solderless breadboards. And what we do is we plug wires into these to set up our circuits. Now, if you look, these 5 holes are all connected. These 5 holes are all connected, but they're not connected to each other. So, in this entire line, each of these, the 5 holes are connected. Each of these, the holes are connected, but they're not connected across this gap. So as long as you're in these 2 columns, they're connected. Up here, the entire line is connected. Do you see this red line? That entire line is connected. And this blue line, the entire line over here, is connected to itself. The blue line on this side is not connected to the blue line on that side. The red line is not connected to the red line. Now, these 2 lines are also not connected. I just find it handy, since they're labeled plus and minus, that when I set up my circuits, I actually make ground the blue, and I make my 5 or 12 volts when I'm working with red. Since these are not connected, if you have a circuit that has dual voltage, you could put 5 volts on this side and say 12 volts on this side. One last sort of beware of, every once in a while you'll see a board like this, and you see how this is an old one I have, but you see how there's a break in the blue line and in the red lines. And what that means is these are connected along here, but they're not connected to these on here. Now this can get you every once in a while if you just grab, I've got several of these. If I just grab one and I'm not paying attention, and I pick one of these up and I plug my power in, say here, and I try to get the power off here, it doesn't work. So a simple solution to that is to just put in little bridge, a little wire connecting these 2 right from the start. And then if you want to pull it out for some reason, that's fine, but at least you won't get trapped by this little problem. Until the next time, thank God for your blessings, and thank the men and women in uniform, the police, fire, military, for your safety. Thank you for watching this video.